Assalamualaikum and hello everyone. Welcome to a new video for chapter 6, 6.3 Chatellier's principle. In this video, we're going to learn to state Chatellier's principle and apply the Chatellier's principle to explain the effect of concentration on a system at equilibrium. So Chatellier's ni is actually a name of a French scientist. Sebab tu lah nama subtopik ni pun Chatelier. Okay, so what is actually Chatellier's principle? It mentioned that when a chemical system is disturbed, it will re-establish equilibrium by undergoing a net reaction that reduces the effect of the disturbance. Okay, so we know that the reaction ni, it is a reversible reaction and it is in equilibrium. So equilibrium tu maksudnya the reaction is balanced lah. Tapi, so sekarang ni it mentioned that when a chemical system is disturbed, so contohnya kita dah tahu the reaction is balanced, but we add, contohnya we increase the concentration ke, we decrease the temperature ke, we add the pressure ke, so what will happen? The system is not in equilibrium dah lah, dia dah tak balance dah. So what happened is that it will re-establish equilibrium by undergoing a net reaction. Dia akan undergo a net reaction to reduce the effect of the disturbance. Dia akan counter back balik what is the disturbance tu lah, apa yang dikacau di situ. Okay, so dia kata kat sini dia akan undergo a net reaction. So what is actually a net reaction? A net reaction tu refers to the shift in the equilibrium position of the system to either right or left. So waktu kita belajar 6.2 reaction quotient tu pun kita ada belajar kan yang pasal the system will shift to the right, system to will shift to the left. Okay, so kat sini I'm just gonna write down apa maksud sebenarnya right dengan left tu. Okay, so we know that for the reversible reaction, the reaction can be in forward reaction where the reactant ni change to product. Arrow dia ke kanan. So that's why kita kata dia adalah selain dia adalah forward reaction, we call it as right lah. The equilibrium tu shift to the right. And then we know that the reaction tu pun boleh jadi juga from the product to reactant. Okay, ataupun kita punya arrow ni akan jadi ke kiri lah. So it is a reverse reaction ataupun kita akan denote it as the reaction will shift to the left. Okay, so nanti kamu janganlah pelik, nanti kita akan banyak guna right left ni. So what does it mean by right left ni? Right tu is a forward reaction where the reactant change to product. Tapi kalau reverse reaction ni maksudnya product ni akan jadi reactant lah. Ataupun left ni, left ni. Sebab arrow dia, ikut arrow dia to the left, ke sini lah, to the right, ke sana lah. Macam tu. Okay. So, in reaction quotient, so kita ada calculation kan, to be, ada value to be calculated. Tapi for the Chatellier's principle ni, kita akan, it will not be given any value, tapi ada several factors lah kita akan discuss. In this video, we're going to discuss about concentration. Okay. So, waktu kita belajar reaction quotient, Miss ada ajar yang pasal Pac-Man tu kan. Yang Pac-Man macam ni ke, Pac-Man yang macam ni satu. Pac-Man yang ini pun ada satu kan. Shift to the left, ni shift to the right. Okay, tapi dalam case ni, yang concentration ni, Miss suka guna for the equation itself ni, Miss sebab nak tunjuk it is balanced, I like to use a seesaw. Okay, so when it is seesaw, just want to show it to you that the reaction is balanced. Sebab equilibrium tu nak katanya it is balanced lah. Okay, so tak kisahlah berapa mol pun dekat sini. Tak kisahlah kalau sini jadi 2, 3, sini 5, 1 ke, tak kisah. Tapi right now, kita akan assume, kita akan ambil sahaja that this equation, maknanya reaction ni dah balance lah. Sebab tu lah Miss guna. Walaupun ada dua, tapi I'm just gonna denote this red one as my reactant, this green one as my product. Okay, so sekarang ni dia dah balance. Okay, apa yang kita nak kacau sekarang ni? First one is to increase concentration of reactant. So what would happen? Sebab sekarang ni, dia dah balance macam ni kan? Tapi kita pergi increase concentration of reactant. So what happen is that, merah ni bukan size macam ni dah lah. Dia akan jadi lagi besar. Okay, so what happened to our seesaw ni? Seesaw kita ni akan jadi macam ni lah pula. Sebab right now, our red one dah makin besar. So what will happen, it is not balanced, tapi dia tilted kan. Dia dah jadi condong. Tapi dia akan jadi more to your left. So right now, it is not balanced. So sekarang ni, the system ni, yang ini nak guna balik yang guna seesaw ni kan. Nak guna seesaw ni, So which reaction will the equilibrium position shift to? Kita akan tengok macam mana kita nak balancekan seesaw ni. So contohnya kalau Miss nak pergi ke kiri, shift to my left, nanti lagilah kiranya seesaw ni macam lagilah masuk tanah Tapi kalau kita shift to the right, nanti barulah dapat kita punya we will get our seesaw ni to be balanced macam ni. So daripada sini Miss sukalah buat dia terus ke kanan sebab Miss nak balancekan dia kan. Kalau ke kiri nanti dia lagi macam ni, dia jadi macam ni pula. So kalau dia ke kanan nanti dia bolehlah jadi balance. So the reaction will shift to the right. Okay, kalau kamu rasa tak naklah guna seesaw Miss, kalau tak nak guna seesaw pun boleh juga. Kalau tak nak guna seesaw, fikir macam ni So when we increase concentration of reactant, okay, so what happen is that kalau boleh kita naklah increase juga concentration of product kita to make sure that kita punya seesaw ni balance. So bila kita nak banyak produk kita form, so maknanya dia nak ke kanan ke dia nak ke kiri. Okay, kalau dia nak ke kanan, produk kita banyak form. Kalau kita buat dia ke kiri, reaktan kita ni lagi banyak form lagi. Sedangkan kita tahu kalau kita dah increase concentration of reactant, kita nak make sure balance, kenalah increase balik concentration of product. Tentu. So that's for the increase concentration of reactant. Next kita tengok macam mana what will be the effect kalau kita decrease the concentration of reactant. So maknanya right now my red one will be a small one. Sebab the green one ni kita tak kacau apa-apa produk kita tak kacau apa-apa lagi. Sekarang ni this will be the effect. Kan dia lagi small kan? Okay, so bila it becomes smaller, it is not balanced. Tapi dia sekarang ni it is tilted more to our product lah kan? Maknanya dah akan ke kanan lagi. Sebab sini lagi berat lagi lah daripada kita punya merah ni. Okay, so what will happen? How to make it balance? Kalau kita nak shift to the right, nanti lagilah dia jadi jatuh lagi kan? Jadi lagi straight macam ni lagi. So, how to make the seesaw balance? Dia akan shift to our left. So, kat sini dia akan ke kiri lah to make sure that our seesaw is balanced. So decrease the concentration of reactant, equilibrium will shift to the left. Okay, sebab kenapa shift to the left? So shift to the left ni kita punya reactant ni bertambah lagi. Sebab sekarang ni when we decrease the concentration of reactant, kalau boleh kita nak increase lah balik kita punya reactant tu. So how to increase back our reactant? Kita nak ke kiri pula. Kita nak our product ni change to our reactant. Ataupun nak buat in terms of seesaw pun boleh juga. Okay, next one. Increase concentration of product. So, just now, we only disturb our reactant. If we disturb our product. So, first one, increase concentration of reactant. So, the green one yang akan jadi lagi besar. So, it is not balanced. So, bila dia tak balance, dia jadi macam mana? So, sama juga. Kat sini, dia macam tilted macam ni kan? Sebab kali ni, merah kita sama saja. But right now, kita increase concentration of product kita. So, what would happen is that, it is not balanced kan? So, kita akan ke kiri. To our left. So, right now. So, bila dia shift to the left, so nanti baru dapat balance. Sebab, bila kita shift to the left, nanti maknanya, all the product tu dah akan bertukar jadi reactant kita lah. Nanti kita akan increase concentration of reactant kita balik. Okay. So, last one kita akan tengok is decrease the concentration of product. So, here what it mean that kita punya green ni yang kecil pula. So, when it is getting smaller, it is not balanced. So, jadi seesaw kita dia jadilah macam ni. So, sekarang ni takkan dia nak gerak ke kiri. Kalau dia gerak ke kiri, nanti lagi dia so, dia akan shift to the right. So, dekat sini, jadilah equilibrium will shift to the right. When we decrease the concentration, sistem tu kalau boleh dia nak increase balik concentration of product kita. So, that is for the introduction. So, let's look for the example itself. Okay, so example number 1 ni, so we have our equation kan, okay. Tapi, I'm just gonna, buat seesaw balik. Tak kisah pun berapa mol. But right now, we're gonna take this one as a balance, it is in equilibrium. So, dia dah balance lah kan. Okay, so first one is actually we're gonna add NO2. So, NO2 ni is actually our reactant kan. So, right now kita nak add NO2. So, what will happen? Merah ni akan jadi lagi besar. Okay, so what is the point? So, kita kena bagi tahulah. First thing first is that the concentration of NO2 ni akan increase. Okay, so sekarang ni the system is not in equilibrium. So, what will happen is that kalau boleh dia nak increase balik lah. If possible, dia nak decrease concentration of NO2 ni. Kita nak decreasekan dia. So, how do we decrease it? Cara lain nak tengok dia in terms of seesaw. Tengok dia akan shift to the right. So, the equilibrium will shift to the right. Okay, so bila dia shift to the right, so it means that kita punya reactant ni jadi produk. So, bila reactant ni bertukar jadi produk, so what would happen is that, bila dah bertukar, so SO2 ni akan decrease. The same goes for NO2. And then SO3 ni akan bertambah lah. Sebab all this reactant dah jadi produk kita. Okay, so kita nampak dekat sini kan, macam mana dia balancekan dia. Bila kita add NO2, sistem ni akan cuba buat, satu, dia akan decreasekan NO2 ni balik. Yang sama, dia akan increasekan produk kita lah, just to make it balance. Okay, so that's for the first one. The second one is remove SO3. So, SO3 ni is our product. So, right now, it is not balanced. So, maknanya SO3 ni kita nak jadi kecil je tinggal dia. So, dia akan jadi macam ni. So, sekarang ni, it is not balanced. So, first kita kena bagi tahulah. So, bila we remove SO3, the concentration akan decrease. And then, the system tu is not in equilibrium. Okay, so what happens is that, dia akan shift ke mana-mana. Kiri ke kanan. Okay, kalau dia kiri, nanti dia lagi jadi cheap. Okay, kalau dia ke kanan, nanti barulah dia boleh jadi balance balik. It will shift to the right. Okay, lagipun sebab bila kita remove SO3, kalau boleh kita nak form lah lagi SO3 ni. Nak counter back, nak apa ni? Nak reduce the effect of the disturbance. Bila tadi dia kata dia remove SO3, the system itself tu, kalau boleh, dah kau buang dia. Tak apa, aku nak. Dia buat lagi SO3 ni. Sebab tu lah dia shift to the right to form many SO3 kita. And to the right, so concentration of SO2 and NO2 ni akan decrease. SO3 dengan NO akan increase. So kita tengok kan, sebab bila kita nak remove SO3, tengok SO3, sistem tu nak counter back balik, dia akan tambah SO3 itself. Last one, for example number 1 is add NO. So NO is actually our product. So sekarang ni kita nak tambah kita punya produk. So what will happen is that the concentration of NO akan increase. Okay, the system is not in equilibrium. So sekarang ni dia nak shift to the right ke shift to the left. So just to make it balance, kita nak dia shift to the left. So bila kita shift to the left, so it means that produk ni jadi reactant lah. Di sini sini. So, from here, so produk jadi reactant dekat sini. So, SO3 dengan NO ni yang berkurang. Tapi, SO2 dengan NO2 ni bertambah. So, that's for example number 1. Okay, example number 2 ni. Okay, yang ini Miss nak buat ni dulu. Okay, so we know that the system is in equilibrium. So, kita buat seesaw, kita balance lah. Okay, sekarang ni Miss nak copy paste dulu Miss punya seesaw jap. So, first one, make sure tengok kita punya, the species tu is either reactant ke product. So, Cl2 is removed. So, here, Cl2 is removed. So, maknanya kita punya reactant berkurang lah. Okay, PCl3. PCl3 is our product, reactant. So, bertambah dekat sini. Last one, PCl5 is added. So, PCl5 is added. Kita punya product. So, first kita tengok Cl2 is removed. So, the concentration dia akan berkurang lah, decrease. So, bila system tu is not in equilibrium, kalau boleh, since it is removed, the system itself nak produce banyak lagi Cl2. Dia nak capai balik kita ni equilibrium ni kan. Kalau boleh dia nak balik yang ni jadi sama size dengan yang ni. So, macam mana dia nak sama size tu? Okay, yang itulah. First, kita tunjuk dulu. Yang ni akan shift to the left. So, bila dia shift to the left here, so what would happen is that, yang ini, PCl5 ni jadi PCl3 dengan Cl2. So, PCl5 ni akan berkurang, sebab dah bertukar jadi reactant lah, PCl3 dengan Cl2. So, tengok. So, di disturbance tu, dia dah counter back dah. Next is PCl3 is added. So, concentration dia increase. Okay. The system is not in equilibrium. So, sekarang ni akan shift to the right. So, bila dia shift to the right, okay, so maknanya reactant ni semua jadi produk. Kan? Jadi arrow dia ke sini lah. So, PCl3 dengan Cl2 ni berkurang sebab dia dah jadi PCl5. So, PCl5 increase. So, nampak ni. So, bila PCl3 is added, sistem tu akan buat supaya dia balance kan. Dia kurangkan balik PCl3. Macam tu. Last one is PCl5 is added. PCl5 yang ni pula. So, concentration dia akan increase. The system is not in equilibrium. Sebab dari besar sini kan. So, kita tengok dia nak shift to the right ke shift to the left. Sini sebenarnya nak shift to the kita punya left. So, bila PCl, when the system to the left, so maknanya PCl5 semua bertukar jadi PCl3 dengan Cl2. So, PCl5 ni berkurang, tapi PCl3 dengan Cl2 ni bertambah. Okay, so that's the end of this video where we have looked for the Chatelier principle dengan concentration. Okay, kalau concentration ni, kita tengok dia in terms of seesaw lah. Nampak tak? Sebenarnya chemical, chemical system pun dia nak capai balance in life. Kita pun kenalah macam tu. Okay, so that's it for this video.